Okay, this is Professor Garb here with the first problem in section 4.1, which is an introduction to polynomials and their graphs. So, in addition to the notes that I've uploaded, the activities uploaded, and the PowerPoints, these are just some worked out problems right from HALKS to give you a vast array of resources. Okay, so does one x equal 1 solve this polynomial equation? So for this particular problem, we would just put in 1 and see if it balances the equation. So it'd be 4 times 1 minus 9. Does that equal 4 plus 13? Okay, so you're going to get 4 minus 9, so it's not, right? Because 4 minus 9 does not equal 17. So we're going to say no on that one. Does x equal 4? Well, that's the same idea. Okay. Does x equal 4? So that's called a 0, by the way. So a 0 means that it's a value for x that will balance both sides. It will make the polynomial have a true equation. So does x equal 4? That's going to be a big number. So it's going to be 3. But before you get worked up, though, just write it out before you start calculating. 3 times 4 to the 7th minus 50 times 4 to the 5th. Does that equal negative? Well, it's not going to be because it's negative, so we know right now. We don't have to go through this crazy calculation and figure all this out. I can tell you right now that's not. Okay, because this whole business over here is going to be negative because you have a negative 7 times 4 minus 22 times 4, so that's all negative, so this is definitely no. So this question asks us to find a degree and leading coefficient. So the degree is going to be degree is the highest power present in the problem. Now in this problem, we could easily see this function that the highest power in this problem is going to be a 2. But I warn you, sometimes you could have something like where you have x squared plus 5x to the third plus 6x to the fourth. It's the highest power is not always in the beginning, so watch out for that, okay? This one is already in order, so when a polynomial is written in the correct order, it's from highest power in descending order to lowest, 2, 1, 0. Okay, so the first power, this is the 0 power. So a polynomial needs to be written as an expression variable to exponents where the exponents go in descending order, highest to lowest. So normally when it's in order, you can just say, okay, there's the degree. So it's degree 2. And it says leading coefficient. So once it's lined up in order from greatest to least power, it's the number in front of the first variable, and if there is no number, it's a 1. So in this case, our leading coefficient is going to be a 1. So let's put those in there and see what part 2 has in store. So our degree is going to be a 2 as the highest power present once it's in order, and then the coefficient of that first of that term, of the degree. So you might notice the numbers have changed just because I wanted to get to the same point in the computer where I can get to part 2, and I don't want to waste your time with that. But this particular problem, as you can see, the degree is also 2, and the leading coefficient is negative 6, okay? The leading coefficient is the number in front of the term with the highest power in it. So this is part 2 right here. They say, what happens to the function as x gets to negative infinity? Well, negative infinity is a really large negative number, so when you square it, so we have negative 6x squared minus 4x minus 11. First of all, when you put a large number in here for x, this is not going to be relevant at all. It's going to be immaterial. It's not going to be as big. So when we square something that's negative, this whole thing is going to be positive, and then we multiply that by a negative 6, and that's going to go towards negative infinity. Okay, so that one's negative infinity. Now the one on the bottom there is x goes to positive infinity. It's going to be the same thing because when you square something that's positive, that's going to be positive. Then you multiply it by negative 6, and that's going to be negative infinity. And again, the negative 4x minus 11 is not going to matter because it's not as big as x squared. Okay, this one here is saying identify all solutions. Okay, so we're trying to find some solutions. We'll do that now. Different kind of problem altogether. So remember what solutions were in the first two problems we did? That's when we're trying to find the number that we put in for x. They ask us, is 4 a solution, is 6 a solution, or whatever. That means if we put that number in, did it balance the equation? Well, this equation is balanced with a 0. So that means we're trying to find the number that we put in for x that makes the left side equal to 0 also. So how do we do that? We're going to learn lots of ways to do that in this unit. We're going to learn how to divide, long division. We're going to learn synthetic division, which is the shortcut. But right now we don't know those methods yet. So right now all we know is we could take out a greatest common factor, a GCF. We're going to try that because we know that from before. So we get x times x squared minus 20x plus 64. And then we look to see if we could, and that equals 0, we'll look to see if we can factor that. All right, so numbers that multiply to 64 and add to negative 20. Well, since they add to a negative, they have to be two negative numbers if that does factor. Okay, so maybe 16 and 4. So it doesn't matter which place you put them in. You can put the 16 first, the 4 first, doesn't matter. But now we have a statement where we have three things that multiply together to give you 0, which means any of them could be 0. So x could equal 0, x minus 4 could equal 0, which means x could equal 4. Okay. This is the one people forget about, the one on the outside. X could equal 0, x could equal 4, or x minus 16 could equal 0, which means x could equal 16. So those are our three answers that we put in there. We don't have to put them in there because it's only part 1. Okay, so we're good there. Next one there. It says solve the following polynomial equation by factoring or using quadratic formula. So sometimes they factor and sometimes they don't. Okay, so what does it mean to solve the polynomial? It means to find the value of x that balances the equation. And there's lots of tools. Right now we just know about factoring and taking out greatest common factor. So, or using the formula if we need to. It says if it doesn't factor, use the quadratic formula. Are there numbers that multiply to 45 and add to negative 7? Probably not, because there have to be two negatives, two positives. And I am positive that there are not two negative numbers that add to negative 7. No siree. 9 and 5, 15 and 3, you're not going to get 7. So you're going to use a quadratic formula. So you're going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. You probably want to know that formula. It comes in very handy. So you're going to have 7 plus or minus the square root of, it's going to be 49 minus 4 times 1 times 45 all over 2. Am I going to get a negative number inside the radical? Let's see. 49 minus 4 times 1 times c. It looks like I'm going to get no real answer. Let us see. So I'm going to get 7 plus or minus the square root of, that's going to be 49 minus 160, 180. All over 2. It looks like I'm going to get an imaginary answer, so I'm going to get some A's and B's. So I'm going to get 7 plus or minus the square root, and we just figured that out. It's going to be negative 131. Sorry about that 3 there. Over 2. And so those are our two answers. It's going to be 7 plus square root of negative 1. Well, it's going to be I. Let's do the I. Okay, let's go down there. So it's going to be 7 plus I radical 131 over 2, and 7 minus I radical 131 over 2. I'm glad I don't have to type that in the computer. I'll leave that for you guys. All right, next one. What do we got here? We got find the degree, two-part question. Well, we know this by now. Actually, we do not. We do, but now you might notice that the function's given to us differently. They give us negative 5x squared, x minus 7, x minus 8. Now this is in factored form, so we have to get a polynomial in standard form, which means we have descending powers, which means this is not in the proper form. We have to multiply this out. Okay, so, and then when we multiply it out, then we get it in standard form, and then we can find the degree and the leading coefficient. So we got to multiply this out. We're going to x squared minus 15x plus 56. And then you have to multiply that by negative 5x squared. So you're going to get negative 5x to the fourth plus 75x to the third minus 250, 280x. So what we really care about for degree is that the powers are descending order, and they are 4, 3, 1. You could skip as long as they go in order going down. So our degree is going to be a 4, because that's the highest power right here. And then the leading coefficient of that term with the highest power is a negative 5. So let's put those in Hawks and see what part 2 yields us. And I'll make sure to hit the submit button instead of skip. That's what happened to me last time. So it's going to be negative 5. So let's go over here. So there's part 2 right there, and they're asking us about the end behavior. This is called end behavior. So that means as x goes to negative infinity. So extend the page here a little bit. We'll see that as x goes to negative infinity, this stuff's not going to matter again because it's smaller powers, so it's not going to add up as much. So this negative, anything to the fourth power, that's going to be positive, and we multiply by negative 5, so that's going to be a negative. So it's going to be negative infinity. And then it says x goes to infinity, same thing. As x goes to infinity, this will be positive again. Anything to the fourth power is positive. And then times a negative 5. So again, that's going to be negative infinity. And again, these terms over here are smaller compared to this. So as x gets really, really big or really, really small, it's not going to make a difference relatively. So that's how you answer that question. All right, so the next one here, we have a two-parter. Okay, let's see what they're asking us. Okay, so number 7 asks us to identify the correct graph and then identify the x-intercepts and y-intercept. Well, there's the graph, there's the equation up here. So remember intercepts, or actually zeros we call them, something that balances the equation, so anything that makes 0. So we're looking for x equals 5, a negative 3, or a 1 would make any of those three factors 0. So we're looking for a graph that goes over 5, negative 3, and 1. There's negative 3, 1, and 5. That one looks good. Negative 3, 1, and 5 also looks good. It's not going to be the first one. It could be the second one, third one, or the fourth one, so we have to figure it out. So, how do we figure that out? Well, we probably have to multiply that out to find out. So we'll do that. So let's see, y-intercept. Y-intercept, that's where x is equal to 0. So if x is equal to 0, we can plug this one in. If x is equal to 0, we're going to get negative 5 times 3, negative 15. And then negative 15 times 1 would be negative 15. So when x is 0, y is negative 15. Okay? So it looks like this guy right here. So we could tell which graph it is without having to do that much work. So what we did was, instead, to find where the y-intercept down here, we find out where x is 0. So we put a 0 in right there for every value of x, and I got negative 15. So I'm going to pick that one. And then our x-intercepts, they're going to be right there. They're going to be, I can put them in there for you. Okay, so they're going to be 5, 0, 1, 0, and I think it was negative 3, 0. So those are our x-intercepts, and our y-intercept was 0, negative 15. Okay, stop there on that one. So number 8 asks us to determine the number of x-intercepts that are there and then plot them. Well, again, what that means is it's the values of x that make the equation equal to 0. So we try to factor if we can. That's we got x plus 4x minus 2. So we have 2 intercepts, and they're going to be x equals negative 4 and x equals 2. So it's going to be negative 4, 0 and 2, 0. And those are the points you plot right there. And the graph for that one is going to look like this, because you know the numbers. You know it goes through negative 15 and 5 and 3, and then you click there. All right, now for this problem, they're asking you which graph, and they want to know how do you get it. And if you look here, you'll see if you factor it, you're going to get 6, 0. You're going to get minus 6 and plus 1, so you get 6, 0, negative 1, 0. And you plug in 0, you're going to get negative 6. So that's our y-intercept, and that's going to be this graph over here. This graph here, -1, 6, and -15, that one.